Hello geometry peeps, and welcome back to another fun and exciting video on three-dimensional geometry. We're going to do the last lesson of the week today. We're going to talk about Cavalieri's principle, and this is the moment you've all been waiting for, because we've been talking about Cavalieri for quite a bit of time all year long, because if you remember the little horsey that I had in the beginning of class up on the smartboard, his name was Cavalieri, and people would say, oh, what does that mean? And I would say Cavalieri is a principle that we're going to learn in geometry, and I'm going to give you all the information you need to know about Cavalieri. So guess who's come back? Check him out. There he is. Cavalieri. I'll tell you why his name is Cavalieri, but here's Cavalieri's little problem. He's missing a foot. Okay, can you see that? He took a little visit somewhere else one of the days when I was out sick. He, I don't know, mysteriously disappeared. And then one day he came back with a broken leg, and, the vet was not able to fix his broken leg. So here he is. He can't stand up, so he won't be able to come back to the classroom ever. But here he is, Cavalieri. Okay, my little horse is going to help us explain Cavalieri's principle. Okay, now, those of you who take Latin and those of you who know anything about language, Cavalieri actually means horseman or knight in Italian. So, and that's a Latin-based language. So Cavalieri just simply means that. That's why the horse's name is Cavalieri. But Cavalieri himself was a person. Okay, his name was actually Bonaventura Cavalieri. Okay, and let me just show you this, because I pulled it up on Wikipedia because I thought it was really cool. So here we go. Here is his face on Wikipedia. Okay, so this guy was born in 1598 in Milan, in Italy. He died in 1647. So you think about that, that was like, when America was first starting to get settled. 1620, I think, was Plymouth Rock. Okay, so he was a mathematician. So remember, back in that time, they had people who actually did math and science, and that's what they did all day, is they studied and they learned to make other people smarter, kind of like teachers. So Cavalieri invented or discovered this principle that I'm going to talk about today. All right, so if you take a look at your sheet, this is page 8 in your packet. I highlighted exactly what's important. The areas of the cross-sections of two solids by any plane parallel to a given plane are invariably equal. Then the two solids have the same volume. And I highlighted from that sentence what's important. The areas of the cross-sections of two solids that are parallel to each other, okay, are going to be, if they're equal to each other, then they're going to have the same volume. So again, if you have cross-sections of any volume, of any solid that are parallel to each other, and their dimensions are equal, then they're going to have the same volume. Okay, so there's some pictures here, yay, yay, rah, rah. Okay, but I wanted to point this out to you. Hold on, let me look at my notes. Okay, so if we look at the second sentence, okay, it says right here, in other words, okay, these are your other words. If two prisms have the same height and the same base, those are your dimensions. So if they have the same dimensions, even though they might be oblique, then they are going to have the same volume. So this is an important sentence, and what I'd like you to do, remember those 7 sentences we talked about all year? This is going to be one of those 7 sentences. So it's important for you to realize this is pretty important. Okay, so they gave you some examples, blah, 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 blah. Okay, and what we're going to do right now is we're going to put this away, and I'm going to explain to you what Cavalieri's principle means. Now down here it says, here's a helpful video to visualize Cavalieri's principle. Now I looked that one up right before I came to the video today, and I couldn't find it. So, don't worry about that so much. I'm going to give you a good video. Okay, and then we're going to come back in a few minutes and do these 2 problems on the back. Really easy. All right, here's number 1. Choice 4. Okay, 2 groups of 8 identical blocks are stacked in different ways as shown below, blah, 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 blah. Which choice explains the volumes of these 2 stacks that these two stacks of blocks are equal. And because we're talking about Cavalieri's principle, we know that that's what it is. Okay, and then we're going to come back a little bit and we're going to reword that sentence so that you have that good sentence for your 7 sentences. Okay, so here we go. If you have something that can be stacked, here we go. Here is a stack of, can you see that? Probably not. Okay, here's a stack of CDs. Okay, my Disney classics, love them. Okay, so we've got this stack of CDs. Okay, how many do I have? 1, 2, 3, 4, 5, 6, 7. 7 CDs here, all stacked up together. Now, if I take those 7 CDs and I stack them, I can figure out the volume by multiplying the length times the width times the height. Okay, now, if I take my 7 CDs and I shift them and turn them into an oblique figure, okay, a little hard to see, okay? You see that now they're all stacked. But it's the same 7 videos that I had, same 7 CDs that I had before. What's the difference? They're just in a different kind of place. But if I took their volumes and I added them all together, guess what? They would still have the same volume as my original. Okay, a little hard to see, but pretty easy to understand. So here's another example. Okay, I have 20 quarters right here. This is why I don't do these examples in school. Somebody would say, oh, can I have those 20 quarters? So if you just said that in your head, you realize I'm thinking about you. So here's your 20 quarters. So if you did pi r squared times height, okay, and you figured out the volume, how much silver goes into that stack of 20 quarters, okay, and then you took your 20 quarters and you did this to them. I'm not doing very well, am I? Okay, and you turned it into an oblique cylinder. Realize that the volume of these 20 quarters did not change. Okay, it's still the same volume that you would have gotten had you done this. Okay, so this cylinder and this oblique cylinder have the same exact volume because you're not changing the quarters. Think about that. Okay, so here's my favorite example, and this is the one I'm going to give you to end with. I'm going to put those, don't lose my 20 quarters. Can you see this? Okay, here's a cylinder. Yep, it's almost lunchtime for me too. Okay, so here is my can of tuna fish. Okay, and it's got a particular volume. In fact, the volume is 5 ounces. Okay, drained it's 4 ounces. Okay, but if I figured out, I could figure out how many cubic centimeters or how many cubic whatevers are in this can of tuna fish. So I have 1, and I have 2, and I have 3 cans of tuna fish, and if I stack them and I figure out the volume, it's the same exact volume as if I did this. Okay, I could actually make like all kinds of pretty cool stuff. So I could do whatever I want to do with these 3 cans. The volume of my cans doesn't change when I rearrange the cans. Okay, I could put them this way and I still have 3 cans. Okay, make a little Mickey Mouse head, and I still have 3 cans. So Cavalieri's principle kind of tells us that if you have if you have any number of figures and they all have the same dimensions, it doesn't matter if you stack them or you make them into an oblique cylinder or you rearrange them. Okay, you're still going to have the same volume at the end of the day as you did when you started. Okay, so back to our last little thing. Here we go. Question number 2 on page 9. Okay, question number 2 says, 2 stacks of 23 quarters are shown below. Hey, that's pretty cool. I used 20. Okay, one stack forms a cylinder, but the other stack does not form a cylinder. Use Cavalieri's principle to explain. That's that word, right? Every time you see explain, you're going to use one of your 7 sentences to explain why the volumes of these 2 stacks of quarters are equal. And we're going to write this. If the areas of the cross sections meaning that this circle has the same area as every other circle, are equal. So if all these areas are equal, okay, meaning that they have the same dimensions, Okay, then they will have equal volumes. Seven sentences for success. That's one of them. Okay, we had a couple others before we left each other. Okay, good stuff. Good stuff to know. 3D. Great, great, great chapter to be able to measure your real world because you live in a 3D world. Okay, that's the end of the video for today. Okay, as we look forward, next week we're going to be talking about spheres and pyramids. Okay, and then we're going to like mix it up a little bit, and then we're going to do these things called conjoined figures. Okay, what happens when you put different shapes together? Okay, pretty easy, so you got to know how to do them. Okay, lots of pages on conjoined, and then the following week we're probably going to get into these continuous rotations. So that's it for today. We have lots and lots to do before we run out of space in this packet. Have a great day. Remember, tomorrow's your quiz. I'm going to post that as soon as I get it finished. And that's it. Have a lovely day. Bye.